So question 13 says, use a graphing utility to graph f of x equals x cubed minus 3x plus 4 on the interval -2 to 2 and approximate any local maxima and local minima. So let's start with that. So question A down here, they're actually going to give us these pictures already. So to graph the function, we're going to hit the y equals button to start with. And then we type in the x cubed, so x, and then the up arrow, we have cubed. Minus then, oops, that's not where it's supposed to be though. Come back and delete that. Right arrow, come down. Minus 3x plus 4. That looks much better. Now the window, so if I go to window here, they want to make the x min and max -2 to 2. So -2 to 2. The x scale will probably just be 1. The y min, -4 to 10. -4 to 10. Y scale will probably just be 1, since we're so close together there. So at graph, notice how it does kind of mirror the middle graph here. So this looks like our graph is this one. Now, to do the local maxima, we do have to use the little blue calculate button. So there's this little key on the calculator that has trace on it. And above it has, in blue, calculate. So we do want to get to that calculate. So we hit the second button and hit the trace button. That'll get us to there. And then it's looking for a local maxima. Looking at our graph, the local maxima is going to be this high point over here. So there looks like there's one going to exist. So to find a local maxima, number 4, notice how it says maxima. We're going to go down to number 4, hit enter. Now, to do a local maxima on this calculator, you have to move left of where you think the maximum is. And also, my little spider guy, that's kind of where I think it is, but I have to move left of it. So notice how it goes back down. I hit enter. Notice how it says left bound. So we want to be left of the maximum, hit enter. And now it says go to the right side of it. So we want to go to the right a little bit. We want to stay locally within that vicinity. Hit enter again. Now, when I hit the third time, it says guess. So if I hit the enter button one more time, notice how it takes me there. It does say round to 2 decimal places, but notice how the y value is 6. So remember, the y value is the local maxima, which is 6. And it occurs when x is about -1. So notice if I round that 2 decimal places, -1.00 would still be -1. So -1 is where it occurs, and the local maximum is actually the 6. So again, to do this, I have to kind of do the second button, and then it does the calculate part of that button there. So it's got the little calculate up there. That's what we want. So you got to really pay attention to the keys on our graphing calculator. So if I do that, second calculate, to find a minimum, notice how it's number 3. So, but to actually do the minimum, you have to be left of the minimum. Remember, a minimum is like a valley. So if I go over here, notice how this graph kind of turns and goes back up. This is what's going to be described as a minimum value, is about here. But to actually use the calculator, we have to be left of that. So if we go a little bit left, notice how the graph goes up a little bit. That's going to be a left bound. Hit enter. We then go to the right of that. Notice how it kind of goes up a little bit. Hit enter again. And then we hit enter for a third time, and it will get us to that spot. So notice that the y value is the actual minimum, which is the 2. And it occurs when x is about, if I round that to the nearest decimal, that third 9 is going to make everything move up. So it's going to be the same thing as like 1.00 or 1. It's going to be that value. So remember, when we have that third decimal place, everything's got to round on up from there. So that 9 turns into a 10, if you will, which means that 9 turned into a 1, but then it's all still got to keep rounding on up there. So it turns into a 1. So B says, where is the graph increasing? So if I look at my graph, and we're staying within this interval, it looks like. So from -2 to 2 is what we're looking at as this interval. But notice how it's kind of increasing until it gets to this maximum. So from -2 to -1, it's increasing. And then it's decreasing until you get to 1. And then from 1 to 2, it's also increasing. So from -2 to 1, it's increasing, and from 1 to 2, it's increasing. So it looks like there's this one here looks like the best answer. So where is the graph decreasing? So it's decreasing where the graph is going down. So notice it's increasing until I get to this -1. And then from -1 to a +1, it's actually going down in a decreasing fashion. So notice how the y values are going down between here and here. So that's considered decreasing. So -1 to 1 would be where it's decreasing. And they're including the endpoints there. They're using brackets. Again, if you look at the table as well, so notice that we have to kind of stay between -2, and notice how we'd actually have to really change our scale to be a little bit tighter because it's not really tight enough to do it that way. So you may have to actually change your table, which we're not going to do at this time. But if we go back to the graph, if we hit the trace button, just hit that, notice how your little spider guy kind of flows into play. You can kind of see your y values more clearly that way. So notice how as you go from -2, notice how your y values are climbing until you get to this spot here. They start to slow down a little bit, then they peak out, and notice how they're starting to go back down now. And then they keep going down. Look at those y values, keep going down, and then they start to slow down, and then it turns, and then it goes back up, increasing. So that's kind of how that works with the graphing calculator.